Hey guys, so this is a video going over some connections that you hopefully made last class. And last time we did some activities and you should have seen the points around the unit circle, and there were a lot of the same numbers, like 1/2, radical 2/2, radical 3/2. And where those come from are just 30, 60 special right triangles and 45 special right triangles. And so what's really neat about those points is that in the unit circle, the radius is 1. So all of those points, you're going over x and up y. Well, this should look familiar because if you have a right triangle, if you do x squared plus y squared, you get the hypotenuse 1 squared. So the equation of a unit circle is x squared plus y squared equals 1. And I think it would be a great idea if you add that to your interactive notebook. You could throw it on the page where you have your unit circle where we did the radians and then your points. And or you could put it on your page with your hand trick. So you should also add this to your interactive notebook. This was part of the activity that we did the other day. And so if you have an angle and you want to find sine of that angle, sine is opposite over hypotenuse. Well, that just ends up being y. Cosine is adjacent over hypotenuse. That just ends up being x. Tangent is opposite over adjacent, so y over x. So this is kind of tying in all that stuff we talked about SOHCAHTOA, and that's why we reviewed it, because we are about to get into evaluating stuff on the unit circle, and that is a huge skill that you will need if you're ever going to take calculus. So cosecant, secant, cotangent are just the reciprocal functions. So once you have sine, cosine, tangent, all we're going to do are flip. We're just going to flip these. And again, I would add this somewhere in your interactive notebook if you'd like to add the right triangle so that you remember where it comes from. That's fine. It's up to you. I would definitely add this. Again, you could put it, if you have room, on the page where you did the little hand trick, or you could put it on the page where we drew the unit circle, or if you want to make a new page, that's totally up to you. And so with these two pieces of information, you should be able to do some Delta Math assignments. So I wanted to kind of go through and talk about how to approach these. So I'm going to look at finding a coordinate point on the unit circle. And so if I have a problem like this where it's not telling me part of the coordinate point, but it's telling me the other part, I can use that equation x squared plus y squared equals 1. And I can plug in what they're giving me. So I can plug in this y value here and square it. Now if you square a fraction, you're going to square the numerator and the denominator. So if you take radical 3 and square it, you get a whole 3. If you take 2 and square it, we get 4. Okay. I'm going to solve for x. So I'm going to subtract 3/4 on both sides. Now something you'll want to do is whatever this denominator is, I would turn 1 into that over that. What I'm doing is 4/4 is 1, but I'm getting a least common denominator. This is going to make it a lot easier because once I subtract, I don't have to worry about getting a common denominator. And so 4/4 minus 3/4 is 1/4. Then we can take the square root, and the square root of 1 is just 1, and the square root of 4 is 2. And hopefully you're realizing, oh, I recognize, this particular coordinate point because it's one of those special right triangle points that you're supposed to memorize. And what this means is that, if you go over 1/2 and up, if you go over 1/2 and up radical 3/2, you're going to get this point. And if you were to actually find this angle using trig, or even law of sines, instead of SOHCAHTOA, you would find out what this angle is. And that's what the next Delta Math assignment is about. So I'll talk about that a little bit more in just a sec. But for now, in this section, this is what you're going to do. You're just going to plug in a number, square it, you're going to subtract, solve for the other one. Make sure you get a common denominator. Now the other thing is they show you where the point is. So consider what quadrant you're in. If you're in quadrant 1, it should be positive, positive. Quadrant 2, negative, positive, negative, negative, positive, negative. So because this point is here, I know that my x is positive. So if you end up typing this in and it says it's wrong and you feel really good about it, it's probably just because you forgot the sign. Alright, so let me go to, get rid of this. Let me go to the other Delta Math assignment so that you can see what I was talking about with using trig to find the angle. Okay, so this is really a lot of review from when we talked about SOHCAHTOA. And like I said, you could use SOHCAHTOA or you could do law of sines, because I know a lot of you like that. And it is pretty simple, so just do what works for you. So when we're plotting that point, we're going over so much and up so much. Well, this also really ties into what we just wrote here, because sine is y. So if I'm looking at a coordinate point, sine is y and cosine is x. Well, if sine is y, sine is opposite over hypotenuse. So this is opposite over hypotenuse. This is adjacent over hypotenuse. So the hypotenuse is 2. And I can put, let's see, so opposite is 1, adjacent is radical 3. This is one way to do it. There are definitely two ways. So this would be one way if you want to think about sine is y, cosine is x. This looks a little bit more like what we're used to seeing with our SOHCAHTOA problems or even a law of sine problem. And then if I want to find this angle, I could do sine of 90 over 2, sine of x over 1, and cross multiply. I could also use sine, cosine, or tangent. So let's say I'm just going to use sine. I could do the inverse sine, where you do like second sine, and then 1/2. And so really, it doesn't require me to draw the triangle, but I just wanted to show you visually why this is what it is. So if from here on out, if this makes sense, if you just want to do the inverse sine of 1/2, you'll get the angle. Now you could also do the inverse cosine of this fraction. So it's up to you, maybe if one fraction's a little bit nicer than the other one. The other way to do this would be, you could again draw a right triangle, and I could do, let's see, so I could put radical 3 over 2 here because I'm going over x and up y, which when this is the case, my radius is 1. So once again, you could do SOHCAHTOA or you could do law of sines and work with these numbers. So I know y'all don't really love fractions, so I thought this might make a little bit more sense. But like I said, you could just do the inverse sine of this or the inverse cosine of x. There's no point in doing tangent because tangent you have to do y over x. And so you'll just be making a little bit more work for yourself. And you're going to have to do that plenty on down the road. So we'll just wait. We'll just hold off on that. So in that assignment, everything else is just review. So these are the only two new things I have for you to do. It's really just practicing Pythagorean theorem, fraction skills, taking the square root. That's really kind of the biggest thing. And this is just reinforcing that idea of the unit circle and that If you were out before and you don't have your unit circle completely filled out, you can do that as well. We already filled in the radians. I didn't put the degrees on there. If you want the degrees, fine. But I do want you to have the coordinate points around your circle. If you don't have room to write around your circle, that's okay. We could just have you do a new circle at a later time. But these are those points on the unit circle that you need to memorize. Everything that's on here with radians and points, memorize it. You do not have to know the degrees, but the degrees are pretty easy. You're just adding 30, 15, 15, 30, 30, 15, 15, 30, and so on. Your radians, remember, from the inside out, it goes 6, 4, and then 3. Those are my denominators. My numerators are all 1, 1 less, 1 more, and 5, 7, 11. Your starting point is 0, and then you're counting a half, whole, 1.5, back to 2. Your coordinate points here are just simple algebra 1, going over 1 up 0, over 0 up 1. And to memorize these points, that's what the hand trick is for. But you could also just, if you can start at 1 up here, go 1, 2, 3, and then 1, 2, 3. So those are a couple of tricks. Also, these points are the exact same points over here. Everything that ends or has a denominator of 6, they're all the same coordinate point. So it kind of goes from in to out. The negatives are coming from the fact of when you plot a point over here, you're going over negative, up positive, over negative, down negative, over positive, down negative. Okay, hope that helps, and feel free to look up more videos if you want to about unit circle tricks or about points on the unit circle, but that's it.